So this topic is pretty much about logic, and logic can be a fun way to kind of go about this. I'm going to challenge you at times to pause the video and see if a lot of this makes sense to you. The first page of this is going to be entirely review. So just as a review, if we're talking about a solution of an inequality, we could have an ordered pair that satisfies the system, or satisfies the equation, but a solution of an inequality in two variables is technically ordered pair or ordered pairs, it could be plural. So we can represent that by a shaded region on a graph, all of the possible ordered pairs that satisfy the inequality. Also, in an inequality that would graph on a two-dimensional plane, we use a dotted line if the inequality symbol in the original problem is a less than or a greater than, and we use a solid line if the inequality symbol is a less than or equal to or a greater than or equal to. So given the system of inequalities, these are the ordered pairs, plural, that satisfy all of the inequalities involved. So this right here represents regions of overlapping, and we'll see that on the graphs that follow. In order to find the solution, we're going to graph the two inequalities on the same plane, and we're going to look at the intersection or overlap of any of the graphs. If we have regions that do not intersect or overlap, there is no solution to the system. So let's start with an example. This is a linear system that we're going to want to take and put into slope-intercept form, so I'm just going to do that really quick. We're going to follow all the rules of inequalities that we learned about before, and I get y is greater than or equal to negative 3x, or 3 halves x plus 3. And I'm going to graph the borderline on this grid right here. So plus 3, and we go down 3, right 2, down 3, right 2, down 3, right 2. I'm going to put every possible point of 3 left 2, of 3 left 2. And then like before, I'm going to put the halfway point. So halfway, 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 and that's about it. So those are all the possible points. And then I'm going to graph that line as a solid line because this is a greater than or equal to. So I'm going to be very careful that I get that part right. Ooh, let me try this again. Solid line all the way through this. Okay. Now the greater than represents shading. Well, what this means, if I interpret this, is that all the shaded values I need must be greater than this line, which means that the y values I shade, y is a measure of up or down, has to be above this curve. Actually, technically, it's like this curve. So that's one reason that I know that I'm going to be shading this region right here, because that region is above the curve, meaning all the y values are more positive than this curve is. But another way I can go about it, kind of a more classic way also, is to test a point. Meaning, let's take the point, let's just take the origin. I'm going to test 0, 0. And I'm going to test it in the original inequality. And when I plug it in, I get 6 is greater than or equal to 0, which is not true. Since it's not true, the region containing 0, 0 should not be shaded, and it is not. We would shade the other side of that line. So let's not get the sides of the line wrong on which side we would shade. Let's try another example of just a linear inequality. If I put this in slope-intercept form, I get negative 4y is greater than negative x minus 12. And then when I divide both sides by negative 4 and switch the sign, I get 1/4 x plus 3. So I'm going to go up 3, put a point. Then I'm going to go up 1 over 4, up 1 over 4, down 1, left 4, down 1, left 4. But I'm also going to do the half point. So up 1, up a half over 2, up a half over 2, up a half over 2, down, down, down. And I'm going to connect all of these with a dotted line, because this symbol is a greater than or less than. It does not have the equal bar. So that needs to be represented with a dotted, broken, or dashed line. Let's make that really obvious that that's a dotted line. And then y is less than means my up-downness has to be down. The y values have to be smaller than my line. So that implies this is the region of shading. Furthermore, let's just check this by testing 0, 0. So if I pick this ordered pair like I did before, 0, 0 is in the shaded region, so I would expect it to work. And if I plug it into the original inequality, I get 0 is greater than negative 12. which is true. And that's what's to be expected because that ordered pair is contained within the shaded region. Okay, moving along. Number 3, if we have at this point done absolute value inequality graphing, then we have a system to split this into a piecewise. If we have not, as I believe in 2020 we haven't done, we're going to do this lesson before we do absolute value. Don't worry so much about this. They won't have these on your assignment, but I'm going to go ahead and do it. What I'm going to do is split this into a piecewise function. So this will be a preview of what's to come. I'm going to split this into y is, well, the borderline of this would be x plus 2 in parentheses minus 3, or negative x plus 2 minus 3. And okay, so that takes care of the absolute value. And if x plus 2 minus 3, if x is greater than or equal to negative 2, and it's negative x plus 2 minus 3 is x is less than negative 2. And that's the, let's see, that's the piecewise function. Let's simplify that a little bit. The first one can be x plus 2 minus 3 is minus 1. Second one can be negative x minus 5. And I get these. So another way to think about it too is that if I plug negative 2 into this, I get negative 2 comma negative 3, which acts as the vertex of this absolute value graph. And then when x is greater than negative 2, I have a slope of 1. So up 1 over 1, which also matches graphing x minus 1 because I have a y-intercept of negative 1. And I would continue that going all the way up. Don't necessarily need to put halfway points here because these are pretty easy to connect. And it's a less than or equal to, so I know that my borderline is a solid line. So I'm going to connect that, but only the pieces to the right of negative 2. Then to the left of negative 2, I have a negative slope. So a negative slope going left is to keep going like this, up and over. And this actually matches the line negative x minus 5, but only the parts of that graph that are left of negative 2. And you can tell that it matches y, or negative x is less than 5, because if this were to continue, it would cross at negative 5. But again, because it's a piecewise, the graph doesn't continue. So this is the graph of the absolute value. Again, if we haven't done this yet in class, then we're going to be doing this in the very next lesson. But y is less than means down. This actually implies that less than, my y value should be smaller than. And if I test 0, 0, which is not a point on this graph, I would get 0, 2 minus 3, negative 1, 0, 0, oops, let's see. That's right, silly me. Plug in 0, I get 0 is less than negative 1, which is not true. So both of that information should tell me that I should be shading underneath the graph. And let's just get this shading looking pretty smooth. I'll be using lots of highlighters because I can. A lot of times you can shade with scribbles, but just be careful that the shading shows kind of right up to the border and that's very easy to read. Okay, so now we're going to be doing multiple ones on the same graph. X is less than 3. Well, if I graphed x is equal to 3, that would be a vertical line. So x is less than 3 is also a vertical line, but it's just going to be a vertical line going like this. And in fact, I kind of want to increase the thickness of this so that we can see it a little bit easier. And I would encourage you to make the vertical lines and horizontal lines a little bit thicker so that you can kind of get an idea of where they are. And then y is greater than negative 1. Well, if I graphed y equals negative 1, I would get this. And that's a greater than or equal to. So that's a solid line. Okay, I don't need that one to be as thick. We'll make that one just a little bit. Oh, I'll cheat and use the ruler on this one because drawing a perfect horizontal line is going to be difficult. There we go. Okay, x is less than negative 3. I'm going to shade this. Less than negative 3 would mean going to the left. So let's get this shading going. Keep that. Let's keep my gaps. And I'll run it up the line just a little bit to kind of make sure that this is somewhat close. Ideally, we should just be right up on that line, but not crossing over it. So that's pretty good. And then I'll shift colors. Y is greater than negative 1 means we're going to go above this line. So if I go up and shade that way, I get this. And I think you can see where the solution lies. The solution is in the overlap of the two regions. So if you were to want to circle that, that's the solution that we're talking about. But I should be able to see that pretty easily on your graph. For instance, maybe if you're going to sketch it with with little sketches, you do like these. Oops, my bad. Don't want to do those. That's not the region to shade. I'd want to do these for one, and then do these for another, so that you can see where the hashtag is, where they cross. But I'm going to kind of erase that up so I can keep my nice, even, clean highlighters, because that just looks a little bit better, at least in my opinion. Okay, let's full screen that again and get this back to where it was. And then let's keep erasing those. There we go. Okay, so here's 3 of them in one. This is much easier than it looks. X greater than or equal to 0. Well, here's x equals 0. Oops, I didn't want to erase that. So 1, 2. Here's x equals 0. And here's y equals 0. So that just means the two axes. Let's shade this a little bit more. There we go. And then x greater than 0 and y less than 0. I think I'm going to combine these into a single area. Greater than 0 for x means, right, oops, sorry, that was greater than or equal to. Here I am putting dotted lines. I better erase that. Maybe draw some straight lines. Okay, so let's keep this closer. Draw a straight line across with an actual pencil. There we go. And let's make this one be vertical. So give me 90 degrees. And then kind of want this to go a little bit to the right so I can get that line looking pretty good. There we go. And erase that. Okay, so x greater than 0 would be to the right, and y less than 0 would be down. I'm just going to shade this region here. This actually means the 4th quadrant. 4th quadrant is a region where x is positive, but y is negative. So it's confined to the 4th quadrant, and then I'm keeping my highlights very limited. So that's one shaded area, and that represents both of these together. So then let's just do the second piece. I'm going to put that in slope-intercept form. Y is greater than negative x minus 1. Negative x minus 1 is a graph that has a y-intercept of negative 1 and a slope of negative 1. So I'm going to put every single point going up and then down. And then I'm going to double-check the style of line that should be. It needs to be a dashed or dotted line. Okay. Oops. There we go. And then this is y is greater than. Well, let's just be absolutely sure about this. If I test 0, 0 in the original, I get 0 is greater than negative 1, which is true. So I definitely want to include the area that contains 0, 0. Y is greater than means up, which is also, they both match the same idea that I'm shading above this line. So let's get this line going. I'll kind of shade the border regions down just to get that. And I can shade across. So my solution is the green region again, the region that overlaps the blue and the yellow. Love how the highlighters do that. But to really get the idea of the solution, it's only this region here. So you can kind of see that it actually chops up just that 4th quadrant, and it's only a part of that. So that gives you an idea of what that looks like. Okay, moving right along. Let's look at two lines, two linear areas. So y is less than 2x plus minus 3. So 2x minus 3 would be here, up 2 over 1, up 2 over 1, down 2 left 1, down 2 left 1. I'm going to put the half points in. And then I'm going to connect the dots with a solid line. So that goes here, connect them with a solid line. I can do better than that, zooming in a little bit. There we go. Okay, then y is less than negative 2x plus 2. Let's get a different Oh, let's go ahead and shade this line first. I might lose track of this. Y is less than means that this is down, so this is below the line. There we go. Okay, that's pretty good. Now let's do the other line. So -1/2 x plus 2, and that's going to go down 1, right 2. Let's put every single possible ordered pair, up 1, left 2. Put every single possible ordered pair, including my half points. Now this should be a dotted or a dashed line because it is a less than, not a less than or equal to. So I'm just going to zoom in on that and spend just a minute doing a nice broken line that tries to get through as many of these dots as I can. That's pretty good. Then we'll come back up, and Y is less than means to shade below that. So that gives me this region, and you can see that the overlap includes the green area, and that is the solution to this system. The solution is the overlap of the two regions. The solution is not a single ordered pair, but it's many ordered pairs contained within this region. It includes the ordered pairs that are on the blue line, but it does not include the ordered pairs that are on the red line. Okay, let's move on to number 7. We have an absolute value. Do not let this mess you up. The absolute value of y less than or equal to 1 meant that y is in between -1 and 1. And we can actually graph that really easily. If y is in between -1 and 1, then I'm going to take the ruler tool. I'm going to graph y equals 1. And I'm going to graph y equals -1. So here's y equals 1. And here is y equals -1. Y equals our horizontal lines. And if my graph is in between those, that's what it looks like. So that's the 1 spot. And then it says y is less than or equal to the absolute value of x minus 1. This is another one that we'll get to a little bit in the next chat part. So we're a little out of order, but we did that so we could give you something a little bit easier before this or during this break. But in any case, if I'm graphing that, I'm going to split this into a piecewise where I have y is equal to x minus 1 whenever x is greater than or equal to 0, and -x minus 1 whenever x is less than 0. Y is less than or equal to. And this really just means that my vertex is the value that when I plug into the absolute value makes the absolute value part be 0. My vertex is the ordered pair 0, -1. So I'm going to put that point right here. Then to the right of that, I'm going to go up with the slope of 1. I'm just going to put every ordered pair down there. And slope of 1. And to the left of that, I'm going to do a slope of -1. All absolute value graphs will look like a V, either right side up or upside down. And then it says y is less than or equal to, so that's going to be shading down. So this is a strange region. It's only the little regions that are on the right and the left contained within that little bar you see from -1 to 1 on y. I'm just shading the whole region in with yellow to make that. So there you go. It's the green regions. Okay, finally, I have this that represents 3 regions. So let's put these all down. X is greater than -1. So I'll put greater than -1. We'll shade that. That's everything to the right of -1 on X. Be careful not to put Y is greater than -1. It's X is greater than -1. X equals our vertical lines. Bucks hoy. Okay, so this gives me everything on that. Then we're going to do y is less than 2/3 x plus 2. So let me do that in a different color. 2/3 x plus 2 is up 2 over 3, up 2 over 3, up 2 over 3, down 2 left 3, down 2 left 3, down 2 left 3, halfway points, halfway points. And less than means a broken line, so I'm going to put a dashed or dotted line. And I'm going to shade underneath that because it's y is less than. So that's shading down below and giving me this region here. But there is one more curve to consider, so we're not done yet. We need to graph 3y is greater than 4x. So this would be y is greater than 4/3 x, which starts at 0, 0 and goes up 4 over 3, up 4 over 3, down 4, left 3, down 4, left 3. Halfway points there. That was up to over 1, 2.5, or over 1.5. So that would be here, and then up to over 1.5 would be here, 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 and here. And it's also a dashed line, so let's keep that broken up. Dashed or dotted. Sometimes my dashes look more like dotted. And this is y is greater than, so this has to be an upward region. So if I shade using even a different color, this doesn't do a great job of completely overlapping everything. You'll notice that it tends to, well, it didn't overlap as well as I wanted to. So what I kind of have to do is I have to direct that this region right here was the region of complete overlap. And maybe using my own shading, I'll darken that region in. We'll put it in gold to say that that was the best region containing all of this. Okay? Good luck.